Welcome everyone. Glad you're able to join us live for this webinar on preparing sites and stores for fast EV charging. My name is Garrett Small and I lead our civil and landscape team here at HFA. I'm joined today with Scott West, one of our mechanical engineers who has a focus on energy efficiency and is a committee member of the International Green Construction Code. Scott, can you tell us a little bit more about your background?
Sure thing. So as Garrett mentioned, I'm a mechanical engineer, so I got my bachelor's in that degree and then went on to also get a business degree for my master's. And when I got out of school, I started working in the industry for design and construction. And I've been working now, I guess, a little over 16 years, and the last 6 of those have been here at HFA. And really my kind of technical focus has always been on energy efficiency and trying to reduce the climate impact of what we do in our industry. And I also started to get involved in commissioning work. And so I really like to focus on how do you take what is in the design intent and actually make sure that it gets started up and implemented that way. And so Garrett, I know you're fairly new to HFA here, and I know you've got a pretty diverse background, and I think it'd be great if you could delve into that a bit.
Yeah, absolutely. Thanks, Scott. Yeah, my background isn't as traditional. I have my undergrad in civil engineering, and then I went into the naval nuclear power programs and spent some time on submarines. Then I jumped ship and went into the construction world in California. And my latest experience has been in the retail world, Scott, where I've driven strategy for new stores, remodels, and even spent some time in merchandising. So Scott, glad to have you here today so we can discuss some of the advancing technology of EV charging and what that means to building our future. After our discussion, we will have some time for questions set aside. There is a slight delay in this webinar, so please feel free to chat your questions as we are speaking, and we'll get to those when Scott and I conclude our discussion. So Scott, I'm not sure about you, but my kids point out all the time the recent surge in electric vehicles on the road lately. And EV technology has received massive attention worldwide and is advancing faster than ever, and that's both in development and in market share. And although the US only has a 6% share of EV on the road today, we're seeing accelerated adoption by US consumers. In fact, it's predicted that EVs will have a compounded annual growth rate of near 40% over the next 5+ years. Add to that, California's thrown out the lofty goal of banning all new gasoline-powered car sales by 2035. This can't happen without the infrastructure to support it, and the government's going to have to play a key role in that. Recently, we've seen the bipartisan infrastructure law, which has earmarked $7.5 billion for EV charging infrastructure for both the grid and chargers. The plan is to have 500,000 public chargers by 2030. Currently, we only have about 160,000 public chargers. But if we're really to hit the goal of 50% of new vehicles sold in the US by 2030 being EVs, it's estimated, Scott, that we'll have to have 20 times the total chargers that we have today. Recently, we've also had the Inflation Reduction Act, which the government is hoping to spur more demand in EV by increasing incentives, not only for individuals, but also with local governments and states. What will this do to consumer behaviors? How do we best prepare for this continuous improving technology? Why don't we start talking a little bit about the charging technology change we've seen over the last few years? Scott, I know you spent lots of time learning about charging and how that is going to be applied to the building code. Can you tell us a little bit about the advances with a focus on level 2 and level 3 charging?
Sure thing, Garrett. So yeah, whenever we talk about the different charging levels of EV, I think it's good to sort of establish a baseline here. And part of that is because these charging definitions have kind of evolved a little bit over the last 5 to 10 years. So I'll start kind of at the most basic level, what's called level 1 charging. And this is what we're used to, just a default 120 volt plug at a single family home. So you can plug right in, and it's really what's referred to as overnight charging. So depending on how depleted a battery is, it could easily be 10 to 12 hours or even longer from there when you're charging at that speed. So you're really at a little under 2 kilowatts at best with level 1 charging. Now, level 2 charging is something you can have retrofit on a home, or it's what you're going to see most typically in commercial buildings that have EV charging currently. And we're still talking about alternating current systems, but it's either going to be 208 or 240 volt supply to serve level 2 chargers. And now we're starting to get into the charge time frame of 4 to 10 hours. And I know that's a big time range, but it does depend heavily on the capacity of the vehicle battery, as well as what the starting charge level is when you pull up to a charger. And in this case, we're talking a range of somewhere between 5 and about 20 kW of peak charging capacity. And next, we'll talk about level 3, which is I think where we've really seen the most changes in terms of what the definition entails. But level 3 has come to mean anything that is direct current fast charging. So if you hear something about electric vehicle fast chargers, they usually are going to fit into this level 3 category, and they use direct current. So there's going to be some type of an inverter that converts AC to DC for charging quickly on a vehicle. And at least in the United States, this has come to mean 480 volt supply. So depending on the size of a commercial building, particularly the smaller ones, tend to only have 208 volt supplies. So right off the bat, we're talking about a fresh utility electric service as being required for level 3 fast charging. And in this case, we're really talking about anything that's 50 kW and up. And I would say for passenger vehicles, we're usually topping out somewhere around 350 kW. So between 50 and 350. And for those that have an intuitive feel of what 100 kW looks like in terms of load, it's a pretty substantial peak load. And of course, the big benefit with level 3 charging is that you're able to charge much faster. So we're now talking about an average of about 25 minutes with these really fast charging stations. And certainly if you're below 150 kW, you're talking maybe between half an hour and 1 hour to fully charge a battery. But either way, we're getting much more on par with what's conventional with gasoline and fueling. And of course, there's some major benefits for uptake of electric vehicles. This is a real key component, is to have these public, non-proprietary charging stations where you can go and top up your battery quickly. And of course, we also have to consider some of the downsides as well. So overall, electric utilities are pretty over the moon, actually, with electric vehicles and moving an entire industry over to buildings and their utility. But when we start to talk about multiple fast charging stations where each one is each 150 kW a pop, you start to quickly accumulate up to the megawatt scale. And so there's definitely some issues and growing pains that are going to happen with this. And I think we're going to see increased usage of demand response programs and what's referred to as vehicle to grid technology, where you have incentives actually being provided to charge during off hours and different ways of limiting even how fast you can charge during those peak times. And Garrett, I think it's important too to consider what this does in terms of the usage of commercial buildings. So convenience stores, for example, retail, restaurant, and now we're talking about having a longer dwell time for customers that come in. So even though fast charging is pretty quick, 25 minutes is still an amount of time that may be longer they'd be staying inside a building. And I'm curious, I know you've done some research in terms of consumer behavior and what this might mean for building owners.
Yeah, although it's hard to predict, Scott, we got to start somewhere. And just like you mentioned, we had slow and low charging that used to be done overnight in garages at single family homes. With these faster charging and these better technology, for batteries, we're starting to see them more on the road and used more. So what used to be a second car now may be a family or a person's only car. So it's still expected that overnight is going to be the main charging for these, just not all of it done at residence. A good way to look at this, though, is look at what we have or what they have in Europe. Although it can't be replicated here in the US, we can start by understanding a few things. And I think the first one, Scott, is they have charging stations at least every 50 kilometers in the countries that have the high adaptation rates. Not something that is well known here in the US or something that we have. But we can also learn from Europe and what they don't like. And that is EV users have complained about the time too. And you've mentioned that a few times. It does take a little bit longer right now. And that's why we're seeing technology constantly change. So with the US, we need to have more charging stations. Because with that is range anxiety. And the biggest problem that we're seeing today with EV users is understanding where those are and where to go. And so most of them are just trips in their town and around the house. How do we help alleviate that range anxiety here in the US, Scott?
Right. So I know the bipartisan infrastructure law is really doing a lot to combat this exact thing. So what we call the bipartisan infrastructure law is actually called the Infrastructure Investment and Jobs Act, which came out, was finally passed in November 2021. And at that point, the Department of Energy and the Department of Transportation came together into sort of a consortium, and they're administering the funds, this $7.5 billion, and they come up with what's called the NEVI formula program. So this is the National Electric Vehicle Infrastructure Formula Program. And it establishes essentially the expected standard for public charging stations. So when we say public, these can absolutely be owned by private sector building operators. And in fact, most of them will be, I believe. But for when we say public is that anyone can come and charge. So it's non-proprietary. There's not just a single manufacturer's vehicle that you can charge there. And it's fast charging. So the minimum charging to qualify for the NEVI program is 150 kW per charging port. And that is even with power sharing between stations. So if you want to charge faster, that's great, but the 150 minimum needs to be met. And part of this NEVI program is also where these charging stations will go. So they've come up with what's called the alternative fuels corridor. And it's very similar to what you mentioned in Europe, where every 50 miles, there's going to be a minimum of 4 fast charging ports at 150 kW minimum. And so essentially they're going to build this out, and it's going to be along the interstate highway system. And I think the first round of funding is going to make sure that those fuel corridors get saturated and built out before we start to expand to more secondary highways. And so this is really to alleviate that range anxiety you mentioned and kind of change the market behavior from just traveling to and from work, charging at night at home, to really being able to drive wherever you like. And I think it's also worth mentioning, of course, you talked about the Inflation Reduction Act, and this one is even newer, was just passed less than a month ago now, and it earmarks $370 billion for climate action, which covers a lot of things, but electric vehicles is a part of that. And the biggest part where we're seeing the funding go through for that is for rebates. So there's already been a rebate program for those that purchase EVs, but now it's continuing and being expanded also to those that purchase secondhand. And there's also work being done on leasing programs. And so I think we're going to see that's going to really help drive demand. And when you combine that with the fact that all the major vehicle manufacturers are actively retooling and working towards moving to EV models, and we're going to see a lot of new models coming online the next 2 to 3 years. It's going to go a long way towards really kind of hitting that compound annual growth rate you mentioned.
Which is a good point, Scott. And with this consumer behavior change and shift that we're seeing, It's really driven a lot by destination. As we have more people using cars in this destination, if you will, cars are going to be parked longer. They're going to be more charging stations in multi-tenant or multi-family locations. And I know there's some codes, Scott, that have actually been developed specifically for this. Cal Green, for example, where they're requiring a certain percent of parking spaces in order to do that. And these codes are changing daily. In fact, we just learned today about something in the Northeast of where we're putting in some spots that we need to have handicap accessibility for some of these parking spaces. Can you talk a little bit about, from the construction code side and Cal Green, what this means and how it can change how we look at sites?
Definitely. So we are seeing a lot of action happening at codes making organizations, and Cal Green is really kind of leading things off here in the United States. So you mentioned Europe as kind of an early adopter to look to, and when we kind of look at what a bellwether looks like in the US, it's really looking at what's coming out of California. And so Cal Green has really upped the stakes with their 2022 version of the code, and that's going to take effect in California January 1st of this next year. And it does a lot of things that we're seeing is starting to be replicated in other codes currently under development. And one thing I think that's worth noting is the definitions of the different levels of installation required is now becoming more standardized. So this has kind of evolved the last few years, but I think where things have shaken out is essentially 3 levels of installation being required. So EV capable is the first one. And essentially what this is it's setting up the infrastructure for EV charging to a parking place. And this involves actually putting in the conduit, whether it's surface mounted or whether it's buried, and making sure there's electric panel capacity, and having a dedicated branch circuit with a spare set up for that. And this way you can come and pull cable when you're ready to put in equipment. The next level is called EV ready, and this has everything that you have with capable, except you're pulling through the wire. You are terminating it at the parking place with a 240 volt plug. So now someone with an electric vehicle and the correct adapter can come plug in, and at your panel you've got overcurrent protection installed. And then kind of the last level of installation is EV installed, or what's often referred to just as EVSE, or EV supply equipment. And this is where you're putting in the third-party equipment, and there's usually going to be an adapter already in there, and it's going to have a connector that matches your vehicle. So in the US, for level 2 charging, for the most part across the board, you're going to see an SAE J1772 type connector. And then from that same standard, we've also seen standardization for fast charging as well. And it's what's called CCS, which is also part of that same SAE standard, but is for the DC fast charging. Now, for Cal Green, we're also seeing a significant number of parking places having to now be reserved for EV charging. And some of it is EV capable, and some of it is EVSE installed. So for base Cal Green requirements, it varies a little bit. It's sort of based on a table, but roughly speaking, we're talking 20% of new parking places need to be EV capable. And then out of that 20%, 25% need to be with the full EVSE installed. And so that's going beyond just the 1, 2, or 3 EV charging stations we've seen kind of being required or incentivized thus far. And Cal Green actually also has Tier 1 and Tier 2 compliance, which jurisdictions can opt into. But once the jurisdiction has opted in, it will be a requirement for that area to do projects. And it becomes even more substantial. So Tier 1 is 30% EV capable, with a third of those spaces being EVSE installed. And Tier 2 is 45% of all parking spaces being EV capable. And once again, a third of those with EVSE installed. And so now we're talking about more than just a couple of breakers and branch circuits, and really having whole dedicated panels just going for electric vehicle charging.
And that adds up quick, Scott. I mean, it's still relatively inexpensive for single-family homes to put this in their garage. But when you start looking at investing in multiple spaces and multiple chargers, that cost goes up quick. And if you don't plan ahead, the cost could be 5, 10x if you're not putting this in the ground earlier. Important to plan when you're looking at that. As we've seen this adoption in, I'll quote, destinations, as cars are parked longer, this is where you should look at putting these in. So airports, some large regional draw commercial. In fact, we've seen that IKEA has come out and said they're going to have 200 ultra-fast chargers installed in some of their locations in the next couple of years. Starbucks, which I know I go to charge my phone amongst many other people, is going to have 15 locations for cars by the end of this year. So some big challenges, a lot of code that you need to navigate, Scott, but with big challenges come big opportunities. And although it may not be tomorrow, we're going to see more cars spending time at destinations, or maybe the destinations or the places with the best charging technology become destinations. So Scott, moving on to when we approach our projects, where do we start? I mean, clearly navigating the code, but where else are you going to look before you jump into big charging potentials on projects?
Certainly. So I think with fast charging projects in particular, it is a bit more than just, we're going to add a branch circuit to a panel we've already got for an electric service we've already got to our building. So now we're talking about it's got to be a 480 volt supply right off the bat. So smaller commercial buildings are already going to be looking at dedicated supplies with utilities. And even for larger buildings, like a large big box, which could accommodate a 480 volt supply for 1 or 2 ports without too many changes, even still, a lot of utilities are starting to trend towards doing dedicated services for fast charging stations and having utility meters on those so that they're understanding what the actual demand and usage looks like over time so they can monitor better. And when we're talking about doing DC fast charging, the types of things you need to plan for, of course, is how many charging stations you want to have, and even looking beyond how many you want to install day one. So do you want to look at having the electrical infrastructure for multiple charging ports, even though you're not putting in the EVSE for those right away? And of course, with all this, the big question is, okay, well, I want maybe a lot of charging stations, but what can the electric utility actually handle locally? And so we're finding that with electric utilities, and I think this is going to come quickly with the more saturation we see of charging stations, and that is to actually be checking with them early in the process and have them even kind of factor into site selection. So here we're talking lots of kW, and it's going to approach the megawatt scale pretty quick in terms of number of charging ports. And so we actually have to be checking with utilities earlier in the process to make sure they've got the capacity.
And it's going to be really key to understand your customer and what your building use is. Mentioned it before. If you're at airports, you're going to have long stays at those, so you probably don't need level 3 chargers. If you're going to have regional draws where they're there for eating or restaurant, you'll need to weigh the fact on what you need to look at. So cost plays heavily into this, and really understanding your customer behavior jumps into that as well. So I know you mentioned corridors and all that, and on the go. Are we seeing any development in those corridors yet, or what kind of rebates?
So yes, within those corridors right now, this is all playing out at the state level, and then the federal funds from the infrastructure law are going to be funneled through states, and each state is kind of approaching things slightly differently, but essentially all the states in the US have sort of an action plan, and they're working through that currently with the federal government. And it's depending on if you qualify or not for a particular location, it's going to involve cash reimbursements for hard costs of equipment as well as soft costs. So the installation and labor required to put some of this equipment in the ground. And it's definitely going to be something that I think is going to incentivize the market. So even for those projects that don't qualify for NEVI funding, or maybe they're oversubscribed for a particular 50-mile increment, I think that it's going to help reduce costs for installing fast charging stations. So being able to bring down equipment costs, because now there's a supply chain built, there's economies of scale, and installers and maintenance personnel now have more experience in doing these types of stations, and that's going to help bring down costs across the board.
A wealth of knowledge, Scott. I hope to rebate some of your time here at the end of the day. I'd like to go ahead and recap a little bit of what you're saying there and kind of focus on 3 things that you need to think about when you're doing site selection. So my takeaway are: understand your customer, and that's knowing what the building use is, understanding what that need is, what kind of power draw could there be. It's knowing your code. It's digging into those local codes, which are ever changing. And then it's engaging the utilities early. And I think that's key, specifically if you're looking at large power draws. I mean, one last thing before we jump to question and answers. I think a big takeaway here is build to upgrade. Technology is rapidly changing.
I'd agree, and Garrett, I kind of add on that too. So we've talked about planning a little bit here, right? So I think even if you're not ready to do a full-blown fast charging station, I think for customer-facing property owners, it's important to start to look at EV charging customers and what that would do with your business model, and how do you start to accommodate that. And even if you're not ready to do a whole bunch of projects, I think being able to do a pilot project is a good way to build experience for what it looks like. It's almost kind of like buying an option on the stock exchange, where you're not sure this huge build out's going to happen in the next 5 years, but in the event it does, and I think it's looking very likely, then you'll be prepared for what that involves.
Excellent. Well, let's go ahead and jump to question and answer here. Scott, and I think this first one's for you. So the question is, when you're discussing charge capacities for charging stations, is that a rate of kW per hour or a total for each vehicle that plugs into charge?
Okay, so yeah, it does vary a little bit. So at least for these fast charging stations for the NEVI program, so I think even though the NEVI funds are only going to go so far, I think that definition of what a public fast charging station is, I think is going to kind of catch hold as a standard. So at least for that program, it's a minimum of 150 kW. But whenever you're plugged in, say, just one vehicle, so these are often set up to power share now. And so if it's just one vehicle plugged in, you may be charging at 175 kilowatts. But if someone pulls up next to you and plugs into the same twin dispenser, now you're only getting the 150 each. And so I think we've the police forces may need to be a little bit wary of road rage or EV charging rage, but yeah, essentially it's still a very fast charge, and there will be some power sharing that occurs if you get lots of demand, but it is limited. So even with that amount of power sharing, we're still talking about some very substantial peak loads.
Excellent. I think this is another one for you, Scott. This is from John. With the addition of EV fast charging at existing locations and new, is there an increase of supplemental green energy sources for these additions, i.e. adding solar or similar?
I've seen a little bit of that, yeah. So I know, for instance, Electrify America has been piloting this approach where they're not only just putting the fast charging, but they're also doing solar PV on canopies, and they're also incorporating battery storage, because obviously the sun shines when it wants to, and solar panels therefore produce power when they want to. And so the storage part is the real key component, because now you can alter the timing of loads versus supply. And so yes, we are starting to see that, but the storage part of it, I think, is the real key. Now, for most solar arrays, at least right now, for light commercial and for residences, they don't have any storage whatsoever locally. For the most part, they're on what's called a net metering setup. And whatever is produced by the sun, essentially you're using the grid as the battery. And so if you're overproducing, you're now sending electrons back to the grid. And those types of systems we're also going to keep seeing increases of. But yeah, I think all of this, the special sauce, or the real kind of when it gets interesting here in a couple of years, is going to be the timing of the demand versus the supply, and it's all interrelated.
And I know there's a lot of testing going on. In fact, I even read the other day about covers for cars that sit at airports to help solar charge as well. So there has been a focus for renewable energy on the grid, and as we start taxing the grid more, I know that's going to be more of an awareness, I guess, with the utilities. So
definitely.
Great question. This is from James. Considering the close contact to higher voltage, what safety measures are in place to protect against accidents or hazards?
Right, very good. So there has been a considerable amount of research and manufacturing. So the various manufacturers of EV supply equipment have definitely put a lot into this over the last 15 plus years. And typically we're seeing emergency overcurrent protection. So they can actually trip if the voltage gets too high or too low. Some of them come with shunt trips. So essentially there's going to be some sort of overcurrent protection, and some of it is going to have to be local. And that is to really help ensure that if something were to happen, maybe a vehicle were to strike a dispenser, that power gets cut in the millisecond time frame. And in addition to that, it's probably worth mentioning too that the connector, so when you actually plug into your vehicle, there's been a lot of work done on making sure that that is also safe. So for instance, the J1772 plug type actually has pins on it which are at low control voltage, and it's detecting that it's got a proximity before it even runs the control voltage. So it goes through what's basically a handshake process from the EVSE to the vehicle itself before it even applies the charging voltage for a vehicle. And it's definitely a really good thing for safety.
This next question is from Phil. So most new builds, the town municipal is requesting the owner to build 3% of total allocated parking spaces to EV stations. Why is this the business owner's responsibility and not the town or government? Well, that's a good question, but welcome to building. It's been everything before, traffic improvements on some projects you have to do, traffic lights. I wish we could get out of it. I wish we could get our clients out of it, but this is where going back to knowing your code, understanding kind of rebates, what that means from incentives of how you can navigate through this. Anything to add to that, Scott?
Oh boy, yeah. That's a very good observation, and it's something that's still forming, right? Because what is the business model for electric vehicle charging? And it's sort of, yeah, depending on the jurisdiction. Typically, the way it's kind of working is sort of the more progressive the jurisdiction tends to be, the more requirements you're going to see in these areas. And for level 2 charging, at least we're only talking a couple of spaces. It's not an energy use that I think you're really going to notice spinning the meter on a building. But when we're talking the type of the quantity of spaces, like for a Cal Green, for example, now we're talking significant energy use. And for the most part, level 2 charging is not something that customers typically are expected to pay for. Now, fast charging is a totally different thing. I think that absolutely the expectation is if you're fast charging, you get the convenience of that, then the customer is going to somehow pay at the charger. And there's been a lot of debate and research into how how does that become a sustainable business model to sell electricity? And it's still being worked out. We haven't really reached that saturation level where there's a lot of price transparency, for example. But I think one thing that's worth mentioning on this is I do expect a lot of utilities to implement time of use pricing. So you're going to see incentives to charge during off hours when it's more convenient, they have a surplus, and to charge more during those peak hours. It's going to be interesting to see how it plays out, Garrett.
Yeah, and we were just talking right before this, where do you even look at separate metering for some of these, or separate metering for some of these spots as well? So there's a lot that we don't know in the future, but we're going to have to plan and try and build for that and protect our clients as we go forward. All right, next question from Edward. Are similar charging systems being used for long-haul trucking EV as well? Very good question, and we didn't touch much on that. I think the technology specifically from long haul is a little bit further away here in the US, but it's definitely where specifically some of our retail clients, we could really look at anticipating that and building for the future like we've talked about. Do we go ahead and put conduit and stations where at the docks the trucks could park and charge while they're there? Now I know you've done some specific code work research on this too, so Scott, would love your input.
Sure, yeah, so it is something that's definitely still evolving. So I think in the last year, it's really come into focus sort of charging for passenger vehicles. But for commercial vehicles, I think there's still a lot of things that are still settling out. And when it comes to long haul, where you're trying to drive as far as you can on a single tank or single battery charge, it's not quite guaranteed yet that that's going to be completely plug-in electric. So I know hydrogen is being looked at quite a bit, and there are other alternative and low carbon fuels as well. But I think it's going to be interesting to watch over the next few years how that develops, because I think it will start to come into focus in the next few years. And yeah, in addition, so on charging stations, we kind of know we're usually talking about sort of up to that 350 kW peak on passenger vehicle charging. But what we're still seeing is what is it going to settle out to be for more commercial vehicles? And so there have been many pilot studies, pilot installations, and research into even faster charging. So we're talking 600 kilowatts, 700 kilowatts per port, even 1 megawatt per port. And so as you can expect for anyone that works in electrical engineering, talking about 1 megawatt per port, and it's very significant capacity.
Absolutely. So I may have misspoke earlier, so I'm going to hit this softball question first. And this is from Jim, where he asked about IKEA 200 charging locations or stations at each store. And if I misspoke, apologies, it's 200 ultra-fast chargers spread across multiple states that they're doing, not for each location. Next one is from Jeremy. How do you deal with limited parking spaces and converting a parking space to EV charging? As an EV owner, icing of EV chargers is a problem. And when you're relying on a charger. Yeah, this is a tough one because it's something that we don't have an answer for yet, and we're going to have to figure this out and build for the future. I think this is part of the issue we have here in the United States and in general as we push towards this. And that's why you're seeing codes like Cal Green requiring 20%. I will say we're actually doing some projects where we're starting to put these, and we know destination trips, for example, on the Cape. So people from Boston going out to Cape Cod where they can stop and charge. I think we're going to have to monitor this closely, and we're going to have to build for it. And at least laying infrastructure up front will help save costs. So when you start retrofitting and then you're playing Tetris on these parking lots to reconfigure, it's not easy, and it does become a puzzle as you start redesigning it all.
Definitely, and I think I'd add to that too that for the most part, when a code is triggered right now, it's when you have a new build, a major renovation, or you're doing something to the parking lot or like resurfacing. So it hasn't happened yet in most jurisdictions, but I think as we get further into this, maybe 5 years down the line, we will start to see some jurisdictions try to enforce EV charging infrastructure on existing buildings that are not otherwise triggering the code.
That'll be a large civil cost. That's why we want to work with our clients up front. This one's from Mike. Are there viable options for decoupling EV charging from EV parking? I've heard of a service that sends out a truck to park alongside an EV to charge from a portable battery. Any chance we might see portable carts, etc., being available to commercial locations so you don't have to park a special spot to charge?
Wow.
Yep, this is new to me.
Where can I invest? That sounds like a good business model. Yeah, I think at least for now, buildings are going to be kind of the lion's share of the market, but I do think there are definitely opportunities for those niche players in talking about something like mobile charging as well.
It's an interesting one.
Yeah.
I'll do some research on that one for sure. Next one, what is the business model? And I think we addressed part of this, but we can touch on anything we missed. What is the business model, and will property owners see a profit on electricity usage alone?
Whew. Yeah, so I definitely think this is something that's still evolving. So if we take Tesla, for example, I think it's pretty widely known that they were allowing fast charging and doing this to try and build up the market and infrastructure for selling their vehicles. And they were subsidizing this. And so they're gradually, I think, getting to a point where they're actually selling electricity and making at least a marginal profit on it. And I know certainly some of the other electric vehicle charging companies. So for example, Electrify America was really created as a result of some of the EPA regulations that Volkswagen got on the wrong side of. And so there was a lot of money that it was compulsory essentially for them to spend to kind of dig out of the hole. And we're just now getting to a point where that's going to start trailing off for them. And a lot of EVSE fast charging manufacturers, I think, have really been kind of priming the pump and just trying to get out there and grab market share. And in the next couple of years, we're going to see, okay, what does this actually look like for profitability? What does this look like for actually having a margin? And what is the volume of customers that you need to get to reach that point? And yeah, I don't think we've got there yet. And it's going to be interesting to see how it plays out. But yeah, it's tough. And I know demand response and time of use pricing is all going to be thrown in there as well. So what is the rate design? Different utilities are offering different rates right now, specific to direct current fast charging. So it's going to be interesting to watch, and I know we're all kind of along for the ride on that one.
Well, and it wasn't planned, so Scott, thank you for leading me into this next question. But California recently asked owners not to charge EVs during peak hours. What changes are necessary to the nation's power grid infrastructure in order to make widespread adoption of EVs less problematic for the grid? Big discussion, and I don't think utilities have an answer. This goes back to also part of the renewable energy discussion as well. And as we tax this grid more, it's going to be a bigger issue.
Definitely. And I think, certain parts of the grid in different states have obviously had well-publicized problems with extreme weather events, and it's something we're all acutely aware of. And at the same time, we're adding a whole bunch of peak loads to the grid and essentially moving an entire industry that had its own fuel supply chain over to buildings. And it is a big change. So far, it hasn't been enough, I think, to really impact grid scale. But I think we're going to get to the point when it is. And obviously, just recently in California, they're asking people to sort of ration. And I think the most kind of ideal way of doing this, I think, is through incentives and price signals. So I think we're going to see time of use pricing. The trend does seem to be that the peak demand pricing, it might be going away, because that's what we're talking about, is demand. And if you talk about demand charges on buildings and trying to add many kilowatts onto that, it could get out of hand pretty quick. And so what I'm seeing on sort of rate design is a move towards time of use pricing. So it's still a per kilowatt hour price, but it's going to be different for different time windows during the day. And all of that comes down to the timing of when these loads hit the grid. And so I think something we'll hear a lot more about in future years is vehicle to grid technology, and actually having some sort of interaction to automatically mitigate those peaks.
I find it interesting, and the hypocrisy is not lost on me, but California requiring all these spaces, which people will use in the day, but then metering what they can use and what they do. So it's going to be an interesting discussion and solution going forward. This one's from Axel. Are there any standardized industry groups that developers, designers, and builders should be reaching out to when considering EV chargers at their projects? Are there any major differences between proprietary charging stations, i.e. Tesla versus anyone else? So I think we're going to see a shift in this real soon.
Yeah, I think from kind of the NEVI program and the infrastructure law that it does appear there's going to be an opening up of what was previously fairly proprietary. So I know Tesla has signaled that they're going to try to move to where anyone can charge, or their vehicles can charge elsewhere. And but there still are differences between manufacturers. So we've looked at this, and depending on if you're talking about, say, ChargePoint or Tesla or ABB equipment, it actually requires different cabling going between your electrical infrastructure and the dispenser. Some have split systems where they've got sort of a power module that sits behind the dispensers themselves, and then there's a bunch of cabling that's a different amount depending on the manufacturer. And yeah, it does kind of make it hard to plan too far ahead, I guess. But at least in terms of getting the main electrical infrastructure out to where a split system starts, I think we've got a fairly good idea of what that involves.
Excellent. Another question. So Scott, when you say 150 kW, what does that mean? Is that 150 kW per hour?
No, I mean that's a peak kilowatt instantaneous. So if so a kilowatt hour, of course, would be running at 1 kilowatt for an entire hour at that same amount. And when we think about energy use within buildings, the peak kW fluctuates, throughout the day and even throughout an hour. And what comes out as a kilowatt hour is the average kilowatts across an hour. And so here we're talking about 150 kW full bore for that entire time period that you're plugged in. And certainly from a kilowatt hour standpoint, yeah, it tends to add up fast with fast charging.
Excellent. And so this last one, I think it's more a comment, but just something to think about how ADA parking space dimensions and access aisles will be affected by adding EV charger to the parking space. And absolutely, I think we've actually mentioned that earlier today. It's really going to be affecting your site design and your parking lot. So how do we incorporate that in there? How do we still meet the ADA standards while meeting the same thing for EV? And if we have minimal EV spots, is it going to be overrepresentative for handicap accessible? So yeah. A lot of questions here. It could take up some of your space, but things we need to be aware about when we're planning our projects. Looks like we're out of questions. So I want to thank everybody for joining us today. If there's anything we missed, or if there are other questions, we're going to be sending out some slides that we went over here as well. So thank you, and just remember, build to upgrade, the technology is changing.
Thanks, everyone.